Dirt Smart, tips and techniques for irrigation technicians, helping you save time and money. This is the outline we will follow in this presentation. First, a quick reference guide. 2 days prior to blowing out with compressed air, open high point vents, low point drains, and allow the system to drain. Identify locations where water collections are likely to occur. Attach a compressor at the highest point possible and introduce air to the system to force the water out of the low point drains. Close the high point vents from highest to lowest points until no water is present from the low point drains. Close the drains from the highest to lowest points. Regulate the compressor air pressure at 35 to 50 psi and activate as many sprinklers as possible while maintaining enough pressure for those sprinklers to run. Turn on each sprinkler head once, forcing water out through the nozzles until a light mist is achieved. As heads are turned off, turn new heads on to maintain continuous flow and pressure. In the low area locations where water accumulates, either remove the riser assembly or insert the hold-up tool 995-102 and activate sprinklers again to remove any residual water. Repeat as required. Last, close off the winterization tap and store riser hold-up keys in preparation for winter. Warnings and cautions. To prevent personal injury, never attempt to disassemble system while under pressure. To prevent personal injury, do not stand directly over any large turf sprinkler when activating manually at the sprinkler. Some more cautions. Do not exceed 50 psi of air pressure in any system. Exceeding 50 psi could result in severe equipment damage and personal injury. Activate each sprinkler only once. Subsequent activations with no water in the sprinkler will result in high-speed activation and excessive pressure spikes, possibly resulting in equipment damage and personal injury. Pressure will build if the compressor is left running and no devices are left open to relieve the pressure. This can cause pressure to build in a dangerous level that may damage the irrigation system and create a hazardous situation. Selecting a compressor. We need to determine the maximum number of sprinkler heads that can be operated at one time with the compressor. By the sprinkler nozzle size and the CMF rating of the compressor, we can do this. So a 30 psi is the minimum pressure required to operate a sprinkler. So an 1.5-inch riserless body opening would be 340 cubic feet per minute at 50 psi. A 1-inch riserless body opening would be 150 CFM at 50 psi. So this chart shows the CFM for each nozzle set at 35 and at 50 psi line pressures, and a 1.5-inch body and nozzle set numbers as shown. Here's a quick example that might make it easy. To operate 11 heads with the X4 nozzle, meaning any of the Toro nozzles that end in a 4, at 50 psi would require a 500 CFM compressor. So that would be an 835-06 with a 34 nozzle, an 854-06 with a 54, a DT54 with a 54, or an Infinity 06 with a 54. You see how that 4 digit lines up with the nozzles 1 through 9 digit. So, and then I have denoted there the 4 with a red rectangle around it. And you follow over to your compressor size at 50 psi, that would be 11 heads. At 35 psi, that would be 12 heads. Golf course systems require a higher volume air compressor. Excessive heat will be generated at the point of the connections of the system. So to avoid damage to plastic piping systems, it's wise to use a 2-inch length of galvanized pipe to dissipate the heat prior to entering the irrigation piping system. The Toro Company recommends the use of pressure gauges installed into the areas where sprinklers are being electrically activated. Monitoring this pressure allows you to maintain the appropriate number of activated sprinklers at any one time. Activating too many heads will result in low pressure in heads that possibly will not operate, and too few heads will result in higher pressures than desired and may cause damage to parts of the system and possibly personal injury. Each crew should have a gauge that will move with them from location to location so that they can monitor the pressure. Electric valve and head sprinklers require a minimum pressure of 30 psi to operate and should not be operated at more than 50 psi to prevent damage. A regulator on the compressor might be fine if it works, or you can use an inline regulator like the one shown. A pressure gauge downstream of the regulator is to verify the pressure is being reduced. Some, it's an option to put right onto the regulator. Step 1. Preparation. Knowing the layout of the piping system is extremely helpful. First, we want to identify the locations of vents we can use to let the air escape. A vent could be a sprinkler head at a high point that we can turn on and or take the inserts out, a quick coupler at a high point, an air release valve, which should be at a high point, or a winterization hydrant. All of these will work. Then we want to identify the location of drains at the low points. Again, we could use a sprinkler head at a low point to turn it on and remove and or take the inserts out, a quick coupler valve at a low point, or a drain valve. Then we want to identify the highest and lowest elevation points on the course, and we want to identify any mainline piping dead ends. Pictured across the bottom of the screen are the different types of things we can use as a vent. The little snap-on tool that Toro makes for the Toro heads, an air release valve, a quick coupler where we put a key in it, or a winterization hydrant. Pictured here are things that we could use in the system to also be drains. So you can see the sprinkler head is again, the quick coupler key is again, and then a drain valve that we might have around the low areas of the course. We might be able to just open those drain valves and let the water drain out. Now in illustration form, we are going to identify the locations of the vents. As you can see from the little symbols here and the little arrows that point to all the different things out on the course that we're going to use as air vents. The arrows here point to everything that we might consider a drain valve when we're winterizing the system. Next, we want to identify the highest and lowest elevation points and identify any mainline piping dead ends or areas where water is known to collect. Step 2. Attach compressor and introduce air. The point of connection winterizing hydrant at a high spot is the best, so we can attach the compressor with a regulator preferably at the highest point possible and introduce air to the system to force the water out the low point drains. If that's not possible or not available, well then maybe we'll connect at the point of the pump station discharge via a well-dolet. It's less desirable if the pump's at the bottom of the property, and the compressor output's limited by the hose size and the connection tap size. There are concerns about the air temperature. As we use the compressor, it may superheat that air as it compresses it. If you've got a compressor that has that disadvantage, then assemble two 40-foot sticks of 2-inch galvanized steel pipe at the end of the hose and use it as a heat sink, and that'll reduce the air temperature entering the system. Keep in mind that a 2-inch bull hose is limited to 400 to 500 CFM. So even if you have a larger compressor, it's going to be pretty hard for you to get to any volume or cubic feet volume higher through that one hose. If you have no other options, you can always introduce air through a quick coupler. The 1-inch air compressor connection is less desirable for a large system, and your output will be limited to what that 1-inch hose's volume and what can get through that quick coupling valve. We're now going to attach the compressor with the regulator at the highest point possible and introduce air to the system to force the water out to the low drains. And we want to close the drains and vents from the highest to the lowest. An example of a drain open, blowing water back into a pond. As we move from highest to lowest, we'll reduce the vents along the way to close that off so air is no longer escaping. Once all the air vents or the drains at the highest points have been removed, we continue on, and one by one, as we get to lower elevations, we'll close off the drain valves as well. Once we get down near the end, we have to remember that we can't be putting the same volume of air in from that compressor if we've only got one drain valve open. So we have to be very quick and very conscious of what's going on between the compressor and how many drain valves or vents that we have open as we do this. Step 3 is to activate the sprinklers and purge the water from the laterals. So while maintaining a maximum pressure of 50 psi in the field, we activate each sprinkler electrically or with the flag key to allow any remaining water to escape. As heads are turned off, new heads must be turned on to maintain continuous flow and pressure. Do not run sprinklers dry for long periods of time with only air discharging. And then we want to shut off sprinklers when the steady stream of water is discharged has ceased. And we'll run through a second time for a short period, and that should be good enough for just about all the sprinkler heads, other than maybe heads in very low areas. In picture form, step 3, this is what it would look like. Maintaining that maximum pressure of 50 psi, activate each sprinkler electrically from the top elevations down to the bottom, allowing any remaining water to escape. As the heads are turned off, new heads are turned on to maintain a continuous flow and pressure. And we continue it moving from the highest elevation to the lowest, pushing the water downhill whenever possible. Here's an example picture of what it might look like as a combination of compressed air and water are spewing out of the sprinkler heads. All the way down to the lower elevations, we want to maintain about the same number of sprinklers running at the same time so that we don't get too high of a pressure buildup or too low of a pressure buildup that the heads won't come on. So we just continue the process as we work down to the lower elevations. Once we get to the very last set, we have to be very careful that somebody's turning the compressor off pretty much at the same time that we're shutting the last sprinkler heads off so that we don't build up any pressure and do any damage in the system. Step 4. In water collection locations, repeat turning on. In a Toro system, the best way to do this is to use this utility tool, a 995-102. It can be snapped on, which will keep the riser in a 3-inch upright position. So the most that riser can jump is another 1.5 inches. And the head can be turned on numerous times or left to run till all the air and water are discharged without doing damage to the sprinkler. Here's a picture showing where mostly compressed air is coming out. We're not really getting any water out. So these would be pretty much ready to shut off. And this is just another visual picture showing where those areas where a pocket might be, or a dead end where water could collect, and that you'd want to hit them in a repeated manner or leave them run for an extended period of time. Use that riserless hold-up tool, and if you don't have that, then turn the sprinkler head to the on position, remove the internal drive assembly. And here's our last illustration, just to show as we've moved down from the highest elevation to the lowest elevation, even in this process, always trying to make sure we're working any water downhill. Step 5, close up the system. Some good things to remember. Obviously, we're going to remove the compressor. We want to close off the winterization tap or taps and store the riser hold-up keys in preparation for winter. We want to collect and store any quick coupler keys that we've used out around the system in the process. We want to close any drain valves that could have water backfeed into them. And we want to leave any other valves open if they're in a place where they could continually drain. And we want to keep good records of just what we did. What did we leave open? What did we leave closed? If we had any issues, we saw any damage along the way, so that we can now get it taken care of. The information we covered today is in this resource document provided by the Toro Company. If you ever have any questions, please reach out to us. We are available, and it's better to ask before damage is done. Thank you. Dirt Smart. Tips and techniques for irrigation technicians, helping you save time and money.